Today I'm going to be talking about a little gadget that we make called Signal Enhancer. What is a signal enhancer? It's a small little gadget, something like this, okay? Perfectly tuned on a spectrum analyzer, okay? And first of all, we design it in the software, and then from software, we actually put it into practice and make the actual antenna and tune it with a spectrum analyzer. And then, of course, that same little device, now what we do is we just slide it over any sort of antenna, let's put it that way. Okay, so what I'm going to do right now is to show you that yes, they do work, and they will give you minimum 33 to 100 and maybe even more actual signal. So just by a small little attachment and small little outlay, financial outlay for a customer, he can improve, he can double his signal to wherever he is getting. And sometimes, you know, you're in a marginal areas where you just need that little bit extra, whether it's for your Wi-Fi or whether it's for your to connect to your tower with your router and things like that. But nonetheless, okay, let's go into the demonstration. Now, what I've got a reference antenna over here, okay, sort of fitted with a coaxial cable going into a portable spectrum analyzer. I will show you now. And then, of course, I've got a little generator over here, which I'm going to do the demo on the Wi-Fi frequency, which is approximately 2.42 gigahertz. Okay, so now basically this antenna transmits into that antenna, and then via the actual cable goes into a spectrum analyzer, and you can actually see the difference in the strength of the signal. All right, let's start from scratch. Right now, our transmitter is transmitting. So let's see, what does it give us? Okay, let me just reset it again. Okay, just give it a bit of time to settle. Okay. So we're getting approximately 66 to 66.5 dBm. Okay, that's a dB milliwatts. Okay, 66 to 66.5. Let me just write that down. Okay. So that is without the actual enhancer. Okay, minus 66.5 dBm. Okay, and you can actually see it on the instrument. Okay. Now, what I'm going to do is I'm going to pick one because we make them for different frequencies, whether it's a 1.8 gigahertz or 2.1 or whether it's a 2.6 to 2.7. No problem for us to actually pre-tune it custom for any frequency customer desires. So what I'm doing right now is I'm taking and I'm putting the actual device over there, which is straightforward. Okay, so now I'm just going to more or less point it towards the antenna, transmitting antenna, and then let's go back to the spectrum analyzer. Okay, let me just reset one more time. Okay. Okay, so, okay, let me just reset one more time. Yeah, we're getting about minus 63 dB. Remember, with the dBm measurements, so let me just write it down, minus 63 dBm. Okay, now that is with a little signal enhancer that I just fitted. Now minus 63, 66, what you call it, 66.5 minus 63, that gives us the difference of about 3.5 dB. which means, and if you look at it on the instrument, yeah, it is still 63, and that's still the enhancer is there. And of course, signal is coming from our small little generator. Okay, now 3.5 decibels. Now 3 decibels means double the signal. Okay, plus an extra 0.5 decibels. So we're getting anywhere between double, 100% to about 130%, 133% actually, 120 something percent extra signal with a simple enhancer that we actually make. And the reason why you're getting, because it is perfectly tuned and it is based on the Yagi-Uda effect on the Yagi antennas. And it's not something new that I have invented. I have just made it and simplified it for customers to use it, because I have not seen anybody make it as simple or as cheap and as robust and easy for customer to use. But yet you can obtain minimum 33 to 100 and something percent extra signal. Yeah, on that note, I have demonstrated the actual signal enhancer, as I said, which you get definite from minus 33 to 100 plus more signal, and very easy fitment. You just slide it over your rubber duck, whatever rubber duck you have. If it's, of course, if you're going to use it for 2.4 gigahertz, then of course you're going to, which is the Wi-Fi, then obviously you're going to be using this particular one, okay, which is the 2.4 to 2.5 gigahertz. Then, of course, if you're using it, say, for a network, which is, say, telecom, you want to connect to a tower, and you got a portable antenna on your router, then you're going to be using, say, for example, 2.3 to 2.4 gigahertz, because that is a telecom frequency for a LTE. And this small little device that I'm holding in my hand will give you anything from 33 to 100 and something percent more actual signal, which will in turn guarantee you of enhancement in the data loads and data transmission between your router and the actual cell phone tower, and also between your cell phone or your computer or your cameras and your router, and which is a significant increase in signal. Yeah, on that note, I have quickly demonstrated, as I said, that yes, it does work, and I showed you on the actual small portable spectrum analyzer that definitely there is an increase more than 120% on my little setup over here. From this antenna, signal goes to this particular antenna, and when I fit the actual, okay, let me just demonstrate it one more time, and I just fit it like that, and Bob's your uncle. There you go. You got 100 and something percent, up to 100 and something percent more signal. Yeah, on that note, till the next time, on the next subject, I hope you enjoyed my quick summary of the signal enhancer that we supply and that we make. And realize one thing, although it does look like a piece of wire or a very simple thing, but it does take time, and it takes a specialized skill and instrumentation to properly tune it. Because if you do not tune it 100%, as a matter of fact, you will actually degrade and decrease the actual signal on your router or your Wi-Fi or whatever antenna you actually going to be using it. Yeah, on that note, thank you for watching Signal Enhancer explanation from Batos Radio and TV. Thank you.